So figure 1.1, this is the first figure of this textbook. The four components of the description of the materials of science and engineering and their interrelationship. Processing, structure, properties, performance. In addition to the structure and properties, two other important components are involved in the science and engineering materials, namely processing and performance. With regard to the relationship of these four components, the structure of materials depends on how it is processed. Furthermore, materials performance is a function of its properties. So this is a figure 1.2. This is an example of these processing, structure, properties, performance relationship. In this figure 1.2, a photograph of showing the three thin disk specimen placed over the printed matter. From the right side, you can see the three thin disks. It is obvious that the optical properties, that means the light transmission of each of the three materials are different. The one on the left is transparent, reflect to the light, and light passes through it. Whereas discs in the center and on the right are translucent and opaque. All of these specimens are of the same material, aluminum oxide. But the left, most of it is what we call is a single crystal that has a high degree of perfection, which gives rise to the transparency. Left side is single crystal. The center one is composed of the number of the very small single crystals. They are connected, and boundaries between these small crystals scatter a portion of the light reflect from the printed page, which makes this material is not transparent. Finally, the specimen on the right is composed not only of the many small interconnected crystals, but also the large number of the very small pores or void, that is air. These pores effectively scatter the reflected light, and material is not transparent. Thus, structure of these three specimens are different in terms of the crystal boundary and pores, which affect the optical transmission properties greatly. Furthermore, each material was produced using the different processing technique. Once again, these three disks are same material, but different processing method. So that apparently we can get very different products. In optical transmittance is an important parameter relative to the ultimate in-service application. The performance of each material will be different. So therefore, here we can understand the structure changed by the processing method. So therefore, processing affect the structure. That means structure depends on the processing method. And different structure show the different properties. And different properties and structure show the different performance. So shall we check this book again? Each chapter rated which part. So this is contents of this textbook again. M is material, PROP is properties, P is processing, S is structure. So the M is materials, M2, chapter 2, 3, 4, 5, 6 is materials, 5 materials, 6 is properties, 7 is properties, 8 is also properties, and 11 is processing. And in the ceramic case, the structure, the properties, and application is performance and processing. So these 4 keywords are included into these chapter 12, 13. And in the case of the polymer, is also same. 14, 15, these 4 keywords are included. In the composite material case, so the 16, only 16. So why do we study material science engineering? That is a very important attitude question. Many applied scientists or engineers, mechanical, civil, chemical, electric, is one time or another exposed to the design problem involving the material, such as a transmission gear, as superstructure of the building, and oil refinery component, or integrated circuit chip. So in every kind of the engineering field, scientists, applied scientists, and engineer should meet the material selection, should meet materials. Of course, material scientists and engineers are specialists who are totally involved in the investigation of the design of the material. Material scientists and engineers are the specialists of the materials, of course. Many times, material problem is one of the selecting the ring material from the thousands available. The final decision is normally based on several criteria. First, in-service condition must be characterized for these decades of the properties require the material. On only rare occasion does the material possesses the maximum of ideal combination of the properties. So the selection of the materials. Thus, it may be necessary to trade one characteristic for another. Classic example involves the strength and ductility. The normally material having a high strength has only limited ductility. In such a case, reasonable comparison between two or more properties may be necessary. Second selection consideration is any degradation of the material properties of the may occur during the service operation. For example, significant reduction in the mechanical strength may result from the exposure to the elevated temperature, for example, or corrosive environments. So the long-time usage is very important. Finally, probably the overriding the considerable is that of the economics. What will finished products cost? Material may be found that the ideal set of the properties, but it's prohibitively expensive. Here again, some compromise is investigatable. The cost of the finished price pieces also includes any expensive incurred during the fabrication and produce the desired shape.